Hey everybody, so we're ready to move on to the next unit, which is called exponential and logarithmic functions. And we'll start off exponential functions with growth and decay. So here's the general form for it. We have f of x equals a times b to the power of x. Now a is known as the initial value. So a is equal to 1, and that's why the y-intercept is also equal to 1. It's how much you started with of some substance. B is known as the growth rate. So we should see pretty easily just by analyzing this graph that from left to right, the function is increasing. So this particular function, when b is equal to 2, is known as a growth function. B is greater than 1, and our function increases as we move to the right. Now, if I played around with this b value, like the larger it is, the faster we're going to increase. Coming from here up, the smaller the value, the slower the increase is going to be. Now, b is not going to be equal to 1 because we would just have a straight line, which is not really what we're after in terms of exponential functions. However, if b is between 0 and 1, we have a decay function. So hopefully that's kind of what you imagine was going to happen in your heads. The function is now decaying. It's decreasing as it goes from left to right. So the function, these exponential growth and decay functions, the b value, what is underneath this exponent, determines whether or not the function has growth or decay. So this one starts off with a very large value, and it starts decaying as we increase the exponent. Once again, if I increase the value of b, so like what's happening here is we are taking b and raising it to the value of x. So like b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 3, and so on and so on and so on, and that's why it's increasing so quickly. Now the a value, again, is the initial value, and it's just going to essentially tell us where's the y-intercept for this particular function rule, where are we starting or stopping, not having a huge role on the actual growth and decay of the function. So that really is going to wrap it up for today's video. You are going to, look at functions and determine whether or not they are growth or decay based off of the rule and the graph. Maybe I can go through a couple of examples with you. Like say we have a function called g of x with an initial value of 4, a growth rate of 0.3 raised to the power of x. So this one is very naturally a decay function because the growth factor was less than 1. The value of b was greater than 0, but less than 1. That's why it is decaying as we go to the right. So definitely with that, I'll see y'all in class. Bye-bye.